Today we're going to look at lesson 1.2, which is the Algebraic Expressions and Models. And this is a great lesson to look at a video because this is pretty much Algebra 1 material, everything that you've done before in Algebra 1 and even geometry. So it's a nice quick review, and if you have any questions you can bring them tomorrow and we'll discuss some of the things that you would have learned last year or last semester. So first we're going to start with a few definitions, pretty short ones. Numerical expression. A numerical expression, when you see this word numerical, what you realize is that obviously it's going to contain numbers. It can also have operations. And hopefully when I talk operations, the first thing you start thinking is addition, subtraction, multiplication, division. We can also think of things like exponents, even parentheses, grouping symbols like brackets. What it doesn't have, it actually two things that it does not have. It does not have an equal sign. If it has an equal sign, that's called an equation. An expression does not have an equal sign. It's not something that we solve. The other thing that it doesn't have is there are no variables. So you won't see a 2x plus 5 or an x squared minus 3. You're just going to have numbers and its operations. You're only evaluating expressions. You're not solving them. The word power is something you use not only in algebra but in geometry. It's just simply a word that means exponents. So for example, if I have 3 to the 4th power, that 4 is the power, it tells me how many times the multiplication is repeated. So that would be 3 times 3 times 3 times 3, 4 times. I want to look at some real basic evaluating just to make sure you're comfortable with some different techniques, and I also want to show you where the button is on your calculator. If you want to do something like 6 to the 5th, you obviously could try to do it in your head. It's a huge number. If you want to do it on your calculator, if you pull out your graphing calculator, here's my calculator here, and you hit your base number first, the 6, and then your exponent button is the caret button. It is the one that looks like the top of a arrow, and what will happen on your calculator, especially if it's a newer calculator, is it'll flash up and be an exponent. If you have an older calculator, you actually see the caret. So then we can hit the number 5, enter, and it'll give us our answer of 7,776. When you have something with decimals and with negatives, then you have to be careful about, are there parentheses or are there not parentheses? This next one actually means that you're going to take 3 to the 4th and then make it negative. So, for example, on your calculator, you can just type in -3 and then the caret and the 4, and it will tell you that it's -81. The difference between that and the next one is the next one has a parenthesis. So what that's actually saying is that negative is also being multiplied 4 times. And when you do that, when you have 4 negatives being multiplied, you end up with a positive. Your calculator will do this for you. If you hit your parentheses button and then -3 parentheses, put the caret and 4, you'll get 81. A faster way to do this is to look at it and go, I know that's going to be positive because anytime a negative is multiplied an even number of times, it's going to be positive. So you could just plug it in your calculator as 3 to the 4th. The last example, 2 to the 3rd, 2/3 to the 3rd. You can do this as separate pieces. So you can actually think of it as a numerator to the 3rd and a denominator to the 3rd. So when you do that, 2 to the 3rd is 8. 3 to the 3rd is 27. If the number before you took it to the power can't be reduced, then neither can the final answer. So even though 8/27, you might have a little question in your mind whether or not it can be reduced, it can't because 2/3 was in lowest terms. You can do that in your calculator if you need to, especially if the numbers are larger, but if you can do it in your head, it'll save you some time. When it comes to evaluating numerical expressions, it's important to remember your order of operations, which usually you learn sometime when you're in RBC. A lot of different memory devices. Most people remember PEMDAS, where each letter stood for a set of operations. P stood for parentheses. It also means any type of grouping symbols, whether it's brackets. It could even be the bottom of a fraction bar or under a square root. E stands for exponents. M and D, multiplication and division. These are together as far as they're equal. Whichever comes first, you do first. So you don't look for multiplication necessarily first. You look for which one comes first when you read it left to right. Same thing with the A and the S for addition and subtraction. They are equal, meaning whichever one comes first, you do it first. Now, when you're doing a problem like the ones that you see here, you have a lot of operations. Your order of operations, the first thing you notice is parentheses in this one. Then you see some exponents. There's a couple ways to do this problem. You can do it step by step, following your order of operations. You can also do it using your calculator because your calculator has been programmed to follow the natural order of operations. So, for example, if I see this problem and I have my calculator right next to me, I can type this in as is. So you're going to see, as I type this in, you'll see the 16 minus your parentheses. You have to put the parentheses where the problem has the parentheses, or else it won't follow the correct order because it's only going to do what you tell it to do. Calculator is only as good as the person using it, so you want to make sure that you're typing things in accurately. So there's our entire expression. We hit enter. We get an answer of 120. We can check that answer. Hopefully that's the answer you got. Oh, that means something went wrong. And this is a good check. We can go back and look. And I'm actually happy this happened because it allows us to correct our mistakes, and I can show you a couple things on your calculator. So if we look at the issue on our calculator, if you hit second and the enter button, you can see your previous entry, and hopefully we can try to find our mistake. We had going back all the way to the beginning, 16 minus 5 plus 9 divided by 3 times 6. Here's what happened. We forgot to square it. And I'm sure many of you were sitting there listening to this saying, why isn't she squaring it? What's the matter with her? But that's okay because we can fix that. When I want to put something in there, I can use the insert button, which I will show you in a second where that is. If I want to insert a squared, I'm going to hit the second button, which is the upper left-hand corner, and then the button that says DEL, delete, that's the insert button. And I'm going to insert a squared. Quick fix, I'm able to go right back through there, and now I get the correct answer. So I'm going to go through here, and I'm going to change this answer and make it more accurate, negative 386. As I said, calculator's only as good as the operator, so you miss one little exponent, you're going to get a wrong answer. Nice to be able to go in and edit your calculator. Why don't you go ahead and try this next one on your own. Again, pull out your calculator, type that in as you see it, go through. You could even pause this video if you don't want to find out the answer too quickly. But you can go through and type all of that in, including parentheses. Don't forget the squareds. Obviously, we saw how big of a mistake it makes when you forget the exponents. I am going to tell you the answer now, but again, you can pause the video if you don't want to be spoiled by finding out the answer too soon. When you punch this all in, you should get an answer of 98. And again, very little work has to be shown as long as you correctly can use your calculator. Next thing we have are some algebraic expressions. We've got some different definitions, and I'm not a big fan of huge definitions. I like to keep things short and sweet. So when you're looking at the first thing, the algebraic expression is just like the numeric expression with the exception of one thing. It has variables. It still has everything else we talked about. It still has numbers. It still has operations. It still does not have an equal sign. We will get into that in tomorrow's lesson, but right now we are just working with expressions that we are not solving. When we talk about variable, and hopefully all of you think variable and the first thing that comes to your mind is x, variable can be any symbol. It doesn't even have to be a letter. It can be any type of symbol. Back in elementary school, you started looking at like smiley faces or apples or oranges, something like that. It is the symbol that takes the place of a number. And we are used to X. That is the most common. But you can have X. You can have Y. You can have Greek letters. You can have Roman some type of letters, different symbols. We will stick mainly with X, but we should be comfortable with it no matter how it's switched. Your terms are the parts that are separated by addition or subtraction. So, for example, if I had 3x squared y cubed minus 5xyz, I have two distinct terms because they are separated by minus. They cannot be combined. They are not like terms. We'll get into that here in a second. And these can be really long. I could have 3x, y, z, w, p, q, r, and that is still one term because everything's been multiplied. It's not until you have that plus something or minus something that you get a separate term. So this right here, two terms. Your coefficient, very easy, is just the number that is in the front of the term. So, for example, in this one, your first coefficient is a 3, and your second coefficient is a negative 5. It tells you how many of that term you have. Your like terms have to have the same variable part, including the exponents. So what I mean by that, 2x squared y and 5x squared y, those are like terms. We can add those together and get 7x squared y. You're basically saying how many x squared y's do you have. If the variables are unlike, let's say they both have an xy, but one of them has a piece being squared. These are not like, because your x is being squared in one of them and not in the other. So we call these unlike terms, and they cannot be combined. When it comes to evaluating basically just means plug and chug. You're taking a number, putting it in for x. And again, you can definitely do this on your calculator, but be careful with the negatives and the parentheses. So for this one, when I put a -2 in and square it, I have to realize that I'm squaring the entire -2, not just the 2. You can enter it in your calculator exactly the way you see it on my screen, or you can do it in your head. So I can look at this and say, well, -2 squared, that's 4, positive. -5 times -2, that's 10. Now I can go back to the beginning and I get -12 plus 10 plus 7. -12 plus 10 is -2 plus 7 is 5. So your evaluation is what happens when you plugged it in. What do you get out? The last thing I want to do in this lesson, again, is very much a review of Algebra 1, is being able to simplify by combining like terms. One thing that I think is the easiest to do is to circle them, underline them, box them. When you see terms like this first one, you look, which ones can be combined? Well, the 6x and the -8x both have an x in it to the first power. So when we add those together, 6 minus 8, we get -2x. Notice that the variable piece doesn't change. You're just saying how many x's do you have. And then same thing with the numbers. -9 plus 10, that's 1. And that's done at this point. We're not solving. We're not figuring out what x equals because there's no equal sign. We're just getting it in a simpler form. For the next one, we're looking at our n squareds. So we have n squared with a 7 in front of it, and then a -1n squared. So that gives us 6n squared. 3n and 5n is 8n. And then this -8, this little guy right here, he's kind of a loner. He doesn't have anything to combine with, so I'm just going to plop him at the end. When we write our terms, we tend to write the biggest exponent first. That's called standard form. But right now, as we're just looking at this, you really can write it anyway as long as your terms have all been combined. For the next problem, you want to distribute. You want to look and get rid of parentheses because then you can see what terms are alike. So remembering distributing means take what's in front and multiply by what's inside. So we get 6x minus 54. Minus 2x minus 14. That negative gets distributed. That's such a common mistake. And then I go through and I combine my like terms. Again, I like to underline. Some people like to circle. Some people like to cross off as they go. 6x minus 2x is 4x. -54 and -14 is -68. And we're left with two terms that are not like, so we are finished simplifying. The last one is a big mess, and it really looks like this problem might take longer. But when you sit down and look at it, what you hopefully will notice is there's a lot of things here that will either cancel or will not combine with anything else at all. So I'm looking at the squareds first because they're the most obvious to me. I see that we have an x squared and a negative x squared, and what I know about those is when I add a positive and a negative x squared, I get 0. So those pieces actually cancel. Now I'm going to look, I have x's. I have just -9x and a positive 5x that are just an x as far as the variable piece. That is -4x. Here's the ones that hopefully you're looking at and going, what do I do with these? These two right here. At first glance, they look like they're different. But what you'll notice is one is an xy, one is a yx. That's the same. X times y times x. We have a property, we call it the commutative property, which says it doesn't matter the order we multiply. Those are like. I like to write them in alphabetical order just to keep them straightforward. So I have a positive 4 and a -6. I get -2xy. And you could write yx and you'd still be right. And then I have this guy right here that didn't have any partners to combine with, so I finish with 4y, and at that point I am done. So that's just a little introduction about what 1-2 is. If you have any questions, we'll discuss it again tomorrow. Think about things that maybe were confusing to you, and that is the end of our lesson.